Okay, so let's start our lecture today. So, yeah. So, last time we are trying to analyze the partial derivative with respect to y. Okay. So, let me write out the equation. Okay. So if we analyze partial f partial y of xy, which is equal to negative 2y a1 squared times 5x squared a2 squared minus 3y squared a1 squared over okay, so x squared a2 squared plus y squared a1 squared. Okay. And then I think the critical values are y equal to zeros, y equal to square root of 5/3. Okay. Okay, so x a2 over a1. Okay. So okay, in this case, okay. Okay. Yeah. So roughly speaking, like so for example, if this is like the y and this is like the x, okay. Oh yeah. Okay. So since I draw it this way, I think so. It's so basically the zeros, they are how do I draw? Like that, right? So y equal to square root of 5/3 x a2 over a1. Okay. 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 So when y is okay. So and then this derivative is negative, right? So yeah. So fy xy is strictly negative. Okay. So when y is bigger than square root of 5/3 x a2 over a1. Okay. Yes. So okay. Okay. Let me see. Okay. So what I'm trying to do is that I'm trying to, because oh, okay. yeah, so let's see whether it can be work or not. So I'm trying to break this whole thing into two pieces. So one piece is the region where it's above this line, right? And then there's another piece where it lies below this line, right? So one is like, yeah, so one is like to the positive y direction, and the one is like to the positive x direction, or like to the to the negative y direction. Yeah, so to the negative y direction. So okay, so okay, so we know that fy of xy is I think it's positive, right? When this y is 1 less than equal to y. Yeah, so when this y is less than equal to, or less than, yeah. Wait, I was confused. Okay. Okay. Okay, so let me think. Yeah, so the function is increasing. So yeah, so I think the question is that what is the Riemann sum that we're taking, right? So so question is that what is the Riemann sum? Okay, so okay. Yeah, I think I also have to analyze the situation about the partial respect to x, right? Because I think in order to analyze like I think one direction is not enough to conclude the lower and upper. Wait. No. Oh yes, I think I'm trying to do is that. Yeah, I'm trying to find an upper bound for the derivative, right? Oh yes, okay. So is there an upper bound for the derivative? Okay. So let's see. So let's try to find a. So what is an upper bound for this y? Right. Or like the absolute value, right? Let's see, on this region, right? Okay, so let's call this region. Okay. So let's call this region omega. Okay. Um, and also I want to include, wait. So let this omega be the set of all x comma y, where so this x and y they must be equal to 1, right? And also this y y is less than square root of 5 over 3 x a2 over a1. Okay. Okay. So, okay. Okay. So, okay, so I know that okay, I think I have something to do with the second derivative, right? What is the upper bound? Yeah, what is the upper bound for this partial f, partial y? What is the upper bound? Wait, do I even need the upper bound? Yeah, I think maybe we can just wait, what am I trying to say? So okay, so wait. So can I just divide this that is into two regions? So one region is the region that is like you using this line to sort of cut everything into like two like separate regions. Yeah. So why? So can I do this? Okay, so yeah, so let's get back to our original function f of xy. Okay, so f of xy, which is equal to n square. So I need the x square a2 square minus y square a1 square over 4 times x square a2 square plus y square a1 square. Okay. So So wait, what is okay? So let me think. Okay.
The function to be strictly decreasing, right? Probably even okay.
Okay, so let's try to compute the partial wait. Yeah, let's try to compute what's the partial relative to x. Okay. So basically, what I'm trying to do is that I'm trying to so basically I want to like split this region, like the function and the Riemann sum into two pieces, right? So one piece is where I'm just trying to show that if this one, the f of xy is, so I definitely know that like over this region like along the y positive y axis, right? Yeah, let's call this 1, and then let's call this 2, right? Yeah, so, yeah, so again, this everything other than, wait. Oh yeah, so I think is xy value has to be taking bigger than 1, right? So you start is 1, 1, and then go like that, okay? So this is the region 2, okay? So I'm on here, and then this is the region 1, okay? So I know that over the region, so I'm kind of gambling that because so here I know that on region 1 the power derivative relative to y is wait, yeah, so on the region 1, right, I know that the positive, yeah, the power derivative relative to y is negative, right? But I'm not sure what happened on the region 1 about the power derivative of x. Yeah. So if I can somehow show that on the region 1, both the power derivative of y and the power derivative about x are all negative. Okay. Then is it true that the function is somehow must be okay. So yeah, so I'm trying to show is that, so if the partial derivative is all negative, does it necessarily imply that if we choose the yeah, so if we choose the what's the orientation? Left bottom ribbon sum. Okay, so if we choose the left bottom corner, yeah. So for example, if you like if you have a like, so this is like the x, and then this has the y, and so this is like the 1 and then the 1. So if you start with like this square here, so namely if I always pick the endpoint that is to the has the least y value and the least x value. Okay. So pick the endpoint that has the least y value and the least x value among all the 4 endpoints. Okay. So is it necessarily the biggest wait. The function is decreasing, yeah. So is it necessarily dominates the function somehow, right? Yeah. So so namely, okay. So first step, maybe it's the okay. So first step, try to compute and analyze function x of this x no y. Okay. And second, so pick the okay. So pick the point with least x and y value for the ribbon sum. And number 3, analyze whether this point dominance. Okay. The block. Okay. So let's compute this partial f, partial s. Yeah, so let's do it here, okay. So yeah, so we have 16 x squared a2 squared plus y squared a1 squared, sorry, to the fourth power. And then we take the duty at the top, which is 2y a2 squared, right? Sorry, 2x a2 squared. And then times the same thing, okay. So let me just erase that. This becomes 8, okay. Times x squared a2 squared plus y squared a1 squared, okay. And then minus, okay. So now we take the same thing and then multiply with the derivative of the bottom one, which is so there is 8 at front. And then there is x squared a2 squared plus y squared a1 squared. And then the derivative inside, which is okay, so the derivative inside. Did I calculate this wrong here? Wait, I think I somehow calculated this wrong at the top. Yeah, so let's see. So okay, so this is equal to what? Times the derivative inside, which is 2x a2 squared, right? Okay, so okay, okay, so these two will actually be cancelled out with one power, right? And together with this term. Yeah, I think there must be something that I'm missing here. I think I may get it wrong for the partial x, partial y. Okay, let's do it again. Okay, so let's just first finish this one. Okay. Okay, so okay. So here, let's move it apart. Okay. So Okay, so let's pull out at 8. Okay, so this is 16 x squared a2 squared plus y squared a1 squared cubed. Okay, and then I pull out a 8x a2 squared. Okay, and then let me more x squared a2 squared plus y squared a1 squared. Okay, this is that, and then minus. Okay. So the 8 is gone, right? So the 8. Okay, so minus. So I pull out at 8. Okay, x squared. So that left is 2. Okay. I pull at 8. Okay, and left with 2. Okay. Times x squared a2 squared minus y squared a1 squared. Okay. Okay, so, and then, okay, so this is 16 x squared a2 squared. Okay, so same thing as the denominator. And then for the bottom one, so okay. Okay. So this is negative 2 x squared a2 squared plus 2y squared a1 squared, right? Okay, so this is times negative x squared a2 squared, right? And plus 3y squared a1 squared. Okay, I think the wait, hold on. I think there might be a little bit tricky for the okay, so yeah, so this is a partial f, partial x. Okay. So what is partial f, partial y? Let's check again. Okay, so let's check. Let's okay, let's check it. So denominator is like 16x squared a2 squared plus y squared a1 squared, right? Okay, shoot, to the fourth power. Okay, so then you first take derivative at the top, which you get negative 2y a1 squared. Okay, and then you times the bottom one, which is 4 x squared a2 squared plus y squared a1 squared. Okay, squared minus. Okay, so you keep top x squared a2 squared minus y squared a1 squared. Okay, and then multiply by the derivative of the bottom. Okay, which is 8 x squared a2 squared plus y squared a1 squared times the derivative inside, which is 2y a1 squared. Okay, so now this one equal to what? Shoot, there's no square here. Okay. Okay, so okay, I want to cancel out this 1 power and also 3 here. Okay. Okay. So okay, so I'm pulling out this negative 8. Yeah, so negative 8y a1 squared at front. Okay. Yeah, so there's a 2 at here, right? And then okay, so x squared a2 squared plus y squared a1 squared. So plus 2 x squared a2 squared minus y squared a1 squared. Okay. Over 16 cubed. Okay. And then okay. Okay. So yeah, so this is equal to negative 8 y a1 squared. Okay. a1 squared. Okay, so the things inside this bracket is 3 x squared a2 squared, right? And then minus y squared a1 squared, right? And then over 16 cubed. Okay. Yeah. So okay. Yeah. Okay. Okay, so let's try to draw this. So, so this is partial f, partial x, okay. And then this is partial f, partial y, okay. So, yeah, so let's try to solve for zeros for this partial f of x. Okay, so I get 3. Okay, 3y squared a1 squared equal to x squared a2 squared. Okay. So y is equal to okay. 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 So zeros for partial f partial y of xy. So this is equal to okay, so y is equal to okay, so y is equal to square root of 3 x a2 over a1. Okay. Okay. Yeah. So slope varies. Okay. So the slope kind of varies by okay. Okay, so and then let's try to analyze this situation. Okay. So what happened to this partial f partial y? Okay. So Okay, so when y is okay, so when y is bigger than this guy, right? Yeah, so then y squared is bigger than this yeah, so y squared is bigger than this 3x squared a2 squared over a1 squared, right? And then you multiply by a1 squared over, yeah. So yeah, so this therefore this term gives you so that means that this part is negative, right? And then this is also negative. Okay, so actually partial y is positive. And then reversely this is negative. Okay. Because y always positive. Okay. Okay. So okay. So let's think about what is this partial x. Okay, so so let's say when this x is what? So this is when y is let's say bigger than this guy, right? Okay, so y bigger means what? So y bigger means that this term dominates this term, right? Yes. So yeah. So so which means that this part is positive. Okay. Yeah, and then you have the partial x is negative when this y is less than this one. Okay. Okay. Yeah, so actually this one has a bigger slope, okay, and this one has a smaller slope. Sorry. Okay, so Let me think. Okay, so yeah, I think let me okay. So I think there are more than like 2 regions here. So let's say let's call this line the y is equal to, so okay, so which one has bigger slope? So this one seems to have bigger slope, right? So then I draw another line that has wait, no. So this is okay. So this is a way that to build the x and y, right? So bigger slope means that same as you may get okay. So I think the slope, maybe this is a bigger slope. Okay. Means y equal to square root of 3 x a2 over a1, right? And then so this is equal y equal to x over square root of 3 a2 over a1. Okay. So okay. So okay, so let's analyze this region, okay, and then we'll do this, and then let's do this. Yeah, so let's break the integral into 3 pieces. So one piece, yeah, and let's say that in region 1, okay. Do I still need to analyze whether this point? Okay. Break the region domain of integration. Into 3 pieces. So, first, region 1, where both the partial derivative are positive, right? Okay, so yeah, and then yeah, so this is what. Yeah, I think in the region one, we can definitely construct a block. Yeah, I'm guessing that. Okay, so I'm constructing that in the region one, since both the product derivative are all positive, right? Wait, they are positive. Okay. Wait. So they are positive, meaning that it's increasing, right? So increasing means that so yeah, so if you view the function like horizontally and vertically, right? So horizontally I mean x, vertically I mean y, along the positive direction, then this function is strictly increasing, okay? So, but so maybe I should pick the oh yes, I think that's the case because if you pick if you pick the wait is this function still yeah, so if you pick the wait so yeah, I have to consider the case where the function could possibly be negative, right? Yeah, I'm thinking about like if the function is strictly positive, then it's increasing in this region. Also, product derivative is increasing in the positive direction. So therefore, I can just pick the point with the least x value and the y value in the block. That I can argue that because the function is like increasing in both directions, maybe it's the point with the minimum value among the block, but I have to consider the case where the function itself is negative, right? So can the function be negative? Let me try to think about this one. Okay. So part A, let's pick the yeah. So let's pick the point with lowest x and y value. Okay, x and y value in each block. Remains up. Okay. Square. Okay. Okay. Okay, so dominant in a sense that yeah. Okay. What is the time now? Oh, okay. I think it's already 1 hour. Okay. All right. So yeah, I guess I'll just stop here and maybe I'll continue next time.